Here's a rigid body kinematics problem which looks at the rotation of a disk which is rotating off center essentially. So you've got this point O right here, which is where the disk is hinged, and as you can see, it's r/4 away from the actual center of the disk, and the disk is rotating about point O basically. So we have to calculate the velocity and the acceleration of point A, where point A is just sitting here on the edge of the disk, and in this particular moment, point A is at the bottom of the disk. So this is the kind of question that you would probably get if you're doing some form of engineering, whether it's mechanical or aerospace or civil. And if you'd like to see anything similar to this on the channel, let me know in the comments. So the way I would do this is I would just use the standard approach, which first I'm gonna look for a point whose velocity I know, and of course we know what the velocity of point O is, and that is 0 meters per second, because point O is fixed. So I'm going to draw my axis at point O. So we have Y, and then we have X, and then of course we have Z, but we don't really draw that because this is a 2D problem. So everything, all rotations happen about the Z-axis. So let's actually write the angular properties, the angular velocity and the angular acceleration in terms of vectors. So we've got omega, the omega vector. So omega, as suggested by the diagram, is inducing a clockwise rotation, which means that omega is going to be minus 2k, and that's going to be radians per second. And then alpha, which is the angular acceleration. So alpha and omega are actually opposing each other in this case. So alpha is going to be 3k, and the units for that, we have radians per second squared. So let's apply Euler's equations. So we're going to apply Euler's equations to find the velocity and acceleration of point A. So first we try to find the velocity. Now, as you know, in Euler's equations, we have to know the distance from the center of our axis to point A. So let's write the equation first. So the general equation for 2D rotation. So we have the velocity of point A is equal to the velocity of O plus, and then we have omega cross OA, like that. Okay, so that's essentially it. So the only thing left to do now is to find what the coordinates of this vector are. So we know that OA can be written as, so A is to the right of point O, which means that this is r/4 times I, right? Because the x distance of A with respect to O is r/4. That's what the question tells us here. And then minus, and then we're going to have r times j, right? Because point A is at a vertical distance of r with respect to O, but it's in the negative y-axis, which is why we have a minus in front of rj. And that's it. So now we can just apply this formula and see what the result will be. But before that, I'm just gonna sub in some values. So 0.16 over 4, that should be 0.04i minus 0.16j. So the velocity of point A will be the velocity of O plus, and then we're going to write the determinant. So we have ijk, and then we write each vector component by component. So omega only has a z component because it's a 2D problem. So this is going to be 0, 0, and minus 2. And then OA is going to have two components. So we have 0.04 minus 0.16 and 0. Right, we also know the velocity of O is 0, which makes things slightly easier. So the velocity of A is therefore equal to I multiplied by, so then we have 0 minus, and then we have 2 times 0.16, and then minus j times, and then we do the same thing. So we have 0 plus 2 times 0.04, so 0.08, which will give us the fact that the velocity of A is going to equal minus 0.32 I minus 0.08 J. Right, so you can see the answer is minus 0.32 I minus 0.08 J, so we showed that the answer is this one. So let's try to understand it a bit before going and finding the acceleration. So this tells us that somehow the velocity at A has two components, and both of those components are negative, right? So you have one component here, and you have the other component here. So let's actually, again, try to understand this a bit. So I'm going to draw a line from O to A. So this is essentially the radius of, I guess, of rotation, or the radius, or just the distance from the center of rotation to point A. And we know that the angular velocity is suggesting that this is rotating clockwise, which means that the velocity of A looks something like this. So we know it's perpendicular. Maybe I should use a different color. We know it's perpendicular to that radius, and it has to point this way because the wheel is spinning clockwise, right? So the velocity of A is pointing in that direction, which means that this will have two components, both of which are negative. So the x component of the velocity is pointing to the left, the y component of the velocity is pointing downwards. Left and downwards, they're both negative, hence we have minus signs. Okay, let's do the acceleration. So the acceleration of A is equal to the acceleration of O. So now we're applying Euler's equation for acceleration. So that's plus angular acceleration and then cross with the same distance OA. And then we can use the trick that simplifies a double cross product into just minus omega squared OA. Remember, this only works. So this is equal to omega cross OA only for 2D rotation. And you can actually prove that, but I won't do that here. So the acceleration of A is going to be equal to 0 plus, and then we have our determinant, so ijk, and then we've got the angular acceleration, which is 3k, so it's positive 3k, so 0, 0, and 3. And then OA is the same as before, so we've got 0.04, we've got minus 0.16 and 0, and then minus omega squared OA. Now keep in mind, omega squared is a scalar, so omega squared is going to be 4, so minus 4 times OA, so OA is 0.04I minus 0.16J. So the acceleration will be given by I multiplied with. So now we do the same thing. We cross out this row and this column, and we get 0 minus minus, so we have 0.48, and then plus, or I should say minus j, times, and then we have 0 minus 0.12, and then minus 0.16i, and then plus, and this should be 0.64j. So the acceleration of A will equal, so we have 0.48i minus 0.16i, so that's going to be 0.32i. And then we have 0.12 plus 0.64, so that's going to be plus, it should be 0.76j. So that is the acceleration, and that's meters per second squared, and the velocity is meters per second. Right. So we have a velocity which has two negative components, and we have an acceleration which has two positive components. And you can, if you want, you can do a similar justification to what we did for velocity, but we're going to stop here, and that's the end of the question.